Uploading.
Okay,
Right.
I'm downloading it. Hopefully.
For those watching on YouTube, we've just made the introductions, and we're going to kick off with a little show and tell, I believe.
Trying to share now. Ta-da. Does it work?
Yeah, looks good.
Yep. All right, so educate us a little bit on CBOM, some of the use cases, maybe. If
Yeah,
you could.
so maybe to just start with some background, right? Where, let's say, the main motivation comes from crypto bill of material, right? It's at the moment we are kind of in a transition phase to a new generation of cryptography, which let's say the main start was about 7-8 years ago with NIST bringing up a call for new public key cryptography standards. So basically key establishment mechanisms and digital signature schemes. So they have been, they received initially 82 submissions for that competition. They don't call it competition, but it's kind of like that. And it went through a couple rounds of evaluations, and then last year, NIST announced basically what the future standards for quantum safe encryption and signatures are. And these are standards that are currently being drafted, and there will be revisions of FIPS standards, and so being released relatively soon, we suppose. And yeah, I mean, that's not the end of the story, but NIST also, they launched a call for new additional signature schemes because they wanted to have some more variety, where the call has ended just recently, and they received again, I think, 40 or 50 submissions that are currently under evaluation. So let's say the summary of that is there is quite some diversity of new cryptographic schemes being that need to be deployed, developed, and deployed. And if we think about cryptography migrations, migrating public key cryptography is, it's not an easy task, right? Because you have to migrate PKI systems, you have to migrate whole stacks of software and so on for this new generation of cryptography. So in the next slide, there is, so shortly after NIST announced the, let's say, the winners of the standardization or the selected standards, the NSA released their CNSA 2.0 advisory last September, where they add a timeline for migration for, let's say, software being used in this case in US government context. And the timelines are, not too far actually. So for example, they have different profiles here. And for web browsers, servers, and cloud services, there is a need to support new quantum safe algorithms, Kyber and dilithium, by 2025, and to exclusively use them by 2033. And now if we try to translate that in somehow in, well, what if this is not fulfilled, there would be a vulnerability, right? So if we just look at a random, more or less random open source software stack like Nginx at the moment, which is not quantum safe, that would be in 2025 have some vulnerability. And similarly, when 2033, if it doesn't exclusively use those CNSA 2.0 algorithms, it would also have another vulnerability. So there is a, can call it here like a bill of policies of weaknesses that could be defined, right, depending on if there is weak or non-compliant crypto used. So on the next slide, there is some, there are some activities like after the standardization has been announced. So the US president last December signed the Quantum Computing Cybersecurity Preparedness Act that basically mandates the prioritization for migration of agencies for post-quantum cryptography. Then also last year, there was a presidential mandate that US agencies shall identify all instances of encryption not in compliance with those new approved quantum-resistant algorithms. And so the US is just one kind of regulation that are being proposed there. There are others, regulations like GDPR, PCI, DSS, or FedRAMP that also mandate certain kinds of cryptography being used. I mean, quantum safe cryptography is not only use case here, right? It's in general, there are policies for all kinds of cryptography. There is also a project from NIST, the NCCOE project for the migration to post-quantum cryptography, where their conclusion for their draft report right now is that organizations are often unaware of the breadth and the scope of application and functional dependencies of public key cryptography within their product, services, and operational environment. And they basically come to the conclusion that a complete inventory of software and vendors is required for that purposes to have, to actually be aware of what cryptography is in the products and in the dependencies there. Now, I mean, that's a requirement, right? But at the moment, there is no standard format really that allows to document cryptography and their dependencies. And that's where CBOM comes into play, right? And especially, I mean, like CycloneDX, right, as one of the main SBOM standards, right? And we kind of see CBOM as really inheriting a lot of the features of an SBOM and adding additional properties for cryptography in it. So basically, if you look at your website, CycloneDX use cases, a lot of those use cases are kind of similar, right? And an extension to it, crypto inventory, right? So we want to have an inventory of algorithms, their properties, cryptographic protocols, right, that use cryptography like TLS or IPsec, certificates. They are bound to some algorithms or keys or other related cryptographic materials. And finally, we want to be able to capture dependencies between what we call your crypto assets. So dependencies can be between components, software components or libraries and crypto assets, or even among crypto assets, there can be dependencies, right? So like an RSA comes with different flavors, right? And might depend on another algorithm or another primitive for hashing, for example. Then I think it's important to have an interoperable exchange format, just because there is, for example, part of this NCCOE project, the vendors come together with their crypto discovery technology that give results of cryptography that is there, right? And we think it's important to have a common format where the results can be transformed or translated in a uniform format like CycloneDX SBOM or CBOM. Then if we have a CBOM, one important thing we think is being able to assess cryptographic risk, right? So in terms of vulnerabilities or weaknesses, let's say if we are not in accordance to certain crypto policies, and we think it's also possible to do some kind of automatic reasoning on the SBOMs or CBOMs in that case that are produced. Then more to the CBOM that we right now published on our GitHub page. So we inherited or we extended version 1.5 of CycloneDX schema specification. And we did it, we did it in a, tried to avoid that anything breaks. So what you can say is that an SBOM of version 1.5 CycloneDX is also a valid CBOM, in our case, version 1.1. The other way around, it's not yet the case, right? Because it's not upstreamed, right? But I think that would be, I think, a good goal here of this working group, right? And right, I mean, extensibility, and even if we only use the CBOM to document crypto assets, we still inherit all the features of CycloneDX SBOM, right? For software composition, to be able to do software composition analysis, vulnerability analysis, and so on. And then finally, we think it's also important to highlight there can be different types of SBOMs or CBOMs, right? That can be produced in different stages of, let's say, development. So either, let's say, just during the design of a software artifact, there is documentation produced, right, that can relate to a CBOM. If you look at source, if you analyze source codes, the results can be a CBOM. During the build process, in terms of CI/CD pipeline, there can be a CBOM as a result. The build artifact, so the binaries can be scanned, and the result can be a CBOM. Even if a software is deployed, right, depending on their configuration, the result can be a CBOM. So there are different types of CBOMs that are possible. So in the next slide, I just have one example of a CBOM that we currently have deployed in context of open source. So there is a project called Open Quantum Safe, which is a collaboration project of different universities and industry partners. We at IBM Research also are contributing to this project, and it's, let's say, the leading project in that aims at providing a quantum safe crypto library and to make open source software components like OpenSSL and software building on OpenSSL quantum safe. So what we have done there is that, so OQS, Open Quantum Safe, already has an internal format that documents all the algorithms it implements. So that's, let's say, a ad hoc YAML file, right, that is used to build HTML sources for documentation. It's not any standard, but still it's in a structured way. So what we did there is a translator script that takes the YAML and produces a CBOM according to our schema. So this CBOM is then part of it's checked into the GitHub repository. And we have some integration also in CI. So always when there is a commit to CI, this CBOM is verified, and so validated against the schema. And it's also checked that if the documentation YAML file updated, we also automatically update the CBOM associated with it. So that's what I would, let's say, if we think about the last slide, that would maybe fit in the design phase, right, of a software, right, where we don't do any scanning, but we have some, let's say, good documentation, and we can use that to produce a CBOM. Right. So the next slide. So here we have a bit more detailed example, and I will just mention what is involved there, and then I would hand over to Nicholas just to show the actual demo about that. So this is about so the setting is we have different scanners, right, that identify, so I call it here, this crypto discovery technologies that identify crypto assets and that produce CBOMs. And we interface with a dependency track, right, from CycloneDX to upload the results and to be able to analyze those projects that we uploaded there for some crypto vulnerabilities. So that, I think, Nicholas, hand over to you just to show a demo about that.
Okay, so you can see my screen, I guess, I hope. Can you see my screen? Yes? thumbs up? Okay, right.
Yeah.
So okay, just for the demo, I will quickly go to dependency track, but just to mention also that for the scanner size to generate CBOM, we decided to use SonarCube for using the static code analysis to detect crypto in use in the source code. So we wrote a plugin that can be plugged into SonarCube and gets us a CBOM. This is Keycloak. I think you're already familiar with, or, you know, this tool. It's an open source Java application. And we just run our scanner over there and it reports the issues to SonarCube, but it also throws, when you run the scan on your CI/CD or on your working directory, it also generates a CBOM for the source code. So that is like one use case to generate the CBOM crypto information about the unwritten source code. But it's not enough to get information and insights about the whole application. So we use then the SBOM capabilities to generate an SBOM from Keycloak in that demo and upload it to dependency track. And dependency track, it's a modified version we are using. It will use the identifier, so in that case, the PERDs of all the components that are provided through the SBOM, and ask a so-called CBOM database that we host and filled with data. That just a simple database that has a table with the identifier and the CBOM associated, which was generated previously. And so when we open the dependency graph of dependency track, it's like the whole Keycloak application. And Keycloaks use, for example, Vertex Core. And we have a CBOM in the CBOM database for that. So dependency track looks in the database, finds that there is a CBOM, gets the information and put it in this dependency graph together. So you get also insights in the dependencies and the crypto there. We also added like a little bit of the UI stuff. So you can see now here on the right side, there's a crypto asset view where you can now go into the algorithm and see also the properties that are associated with the CBOM. So you also can see that here. And yeah, so this is basically the dev side of it. I mean, in the end, or not at the end, but when you go even further, then you would have some kind of scanner for also the container image to get also information about the crypto that's used there when you Dockerize your application. And all those information will be output as CBOM and then put together in one big CBOM that you can then, for example, attest to the Docker image using the standard in toto format, something, and put then in an operational environment where some other application that observes the running instance can get crypto information about the whole application and give you an overview over the compliance state or something. So that's basically how we see the CBOM, that we use it at different stages to put out information, put them together, and also move them forward to other vendors if you're a software producer. So basically like the whole software supply chain SBOM idea, I think it's quite similar. Yeah. Okay.
That was phenomenal. Thank you. Wow. Okay. I didn't realize all this was done. This was very enlightening. Question for you. This view that you're looking at right now, you're looking at Keycloak, you're looking at a crypto asset. Do you envision that everything is going to be a vulnerability? Or is there kind of that in-between thing where, you know, I don't know, maybe you're using triple DES or something, and it's not necessarily a vulnerability, but it's maybe a weakness? Do you see kind of that in-between type of thing?
Yeah, I think I would say it depends on the policy that you have, right? So how we implemented in that case, we use so we have an integration with open policy agent, where you can basically define policy as code, right? And then you would have, let's say, okay, with one policy, triple DES is still acceptable, but with another policy, you would say, no, it's not in policy, right? It's not compliant. And I think depending on that, the policy that you have, the result will be according to that. So we don't say, okay, we just have a fixed view, this is a vulnerability or not, but it depends on the policy that you want to apply.
So currently it's done like Basil mentioned, we have the policy, and then this policy is part of we call it CWE. So it's like the actual core to analyze it, but in the metadata of the CWE, we define this CVSS vector, for example, to say how severe this vulnerability is. And one can imagine to also have there just another field for saying, okay, it's just an information and not a vulnerability or just a weakness. So yeah, I don't know.
Okay, no, that makes a lot of sense. Thank you.
Or maybe even the possibility to figure out if you're using hybrid mode instead of just, you know, switching from classical cryptography to post-quantum cryptography. You can also have a policy that says, okay, hybrid mode is allowed. I can imagine.
Right.
I mean, also to add here is this idea of this policies. Currently, we host it as a single instance, and dependency track and also SonarQube. So both applications we have just fetch those vulnerability information, like those policies, and analyze it on the CBOM that they generate to detect if there's out of policy use or vulnerabilities. And one can imagine to not only have a single instance, but also, like, for example, enterprise specific instance with different policy sets that they are interested in, and they can generate those new ones. And then you can just go to dependency track, for example, and add here, and just go to the analyzer and set the new, to the vulnerability source and add the new URL here for your enterprise
Right.
service. Yeah.
Okay.
Yeah.
Can you go back? I mean, not so interested in the dependency track part. I think we can make those changes, but I'm interested in going back to that view where you're looking at a crypto asset. There was a button to add a crypto asset. Can you go into there and maybe talk about some of the fields? Because that's kind of a visual representation, I guess, of the spec, right? I would assume.
I would assume, I'm not 100% sure when I click on it. No, I would assume that there is no any changes to happen here.
Okay.
So
right.
yeah, we just use the directly API to upload our data. So yeah, not everything was touched. Yeah,
I got it. Would it be possible to kind of walk through the you had, for example, a crypto properties element within the JSON. Can you maybe walk through some of those?
Sure. Should I just share, or we want to do it?
Yeah, whatever's easier.
Okay, then I will just. So okay. I don't know, just Basil mentioned that, Matt, you have a diff of the view. Maybe it's better to show that. I just.
Sure, put me on the spot.
Sorry.
Because I was actually just chatting with somebody in Slack. I was being interrogated. Let me see. I had to reboot my computer due to security updates for Mac yesterday. So I don't have the application up. So let me see if it's saved. The comparison.
Otherwise, what we see is in the crypto properties are basically an external reference right now. So the diff is basically what you see in the cryptographic properties JSON schema.
Yeah,
you can start going through. I need to get the latest 1.5 from the repo.
Yeah, so actually what Basil mentioned. Yeah. Go ahead.
In the main schema, so our extension to 1.5 is extension is relatively minimal, right? So we added this crypto properties reference, external reference. Plus we added one addition, I think, which can be discussed, right? We also had the concept of dependency type. So because we use the dependencies type of CycloneDX, and we added a attribute to it where you can describe if the dependency type is either something is used or something is implemented, right? So I mean, I think one can discuss if this can be solved in a different way, right? Or if we want to do it like that. So, but these are basically the only additions to the core schema, and everything else is in the external schema that we have here. And here and one addition is, let's say the third addition that we had in the core schema is that on the components, we added one component type, which is crypto asset, right? I mean, you have there at the moment, you have things like library, container, framework, and so on. And there we added one type, crypto asset. So if a component is of type crypto asset, we know it's something to do with cryptography. And then we have these crypto properties here in this JSON. And here one thing is we have these asset types which I had on the use case slide, we can have different types of crypto assets. We could either have an algorithm or a certificate, a key, a protocol, or other related crypto material. And then if it's an algorithm, we have here algorithm properties where we have fields like the primitive, it's like a signature scheme or a public key encryption scheme. Ability to describe variants, because I mean, one thing is, you know, that it's AES, right? But AES comes in different flavors depending on how it is used, like AES 128 with CBC padding and PKCS, CBC mode and PKCS 7 padding. And so we have also for some very often used algorithms, we have lists, right? So for example, elliptic curves, we here have a relatively exhaustive list in an enum. So we had a chat with Matt last week, right? How this could be done maybe a bit in a more extensible way by instead using URNs, right? We have the next type is about implementation level, right? Because not all crypto implementations are in plain software. Some use trusted execution environments, some use hardware security mechanisms. We have the platform where it's implemented. We have field about the certification level. So like RSA can be implemented not certified, or it can be in FIPS mode, or it can be implemented with common criteria certification and so on. I mean, again, here these enums can probably be made in a more extensible way, right? We have things like the cipher mode, padding, crypto functions, right? So which functions are actually implemented by an algorithm. And then we think what's quite important is the security level of an algorithm. Here we distinguish between classical security level, which is, let's say, in a pre-quantum world. So AES 128 has 128-bit security. RSA also has some classical security level. Then we have a NIST quantum security level. So in this NIST standardization process, they define security levels ranging from 1 to 6. 0 would be non-quantum safe, where the quantum resistant algorithms are classified in. And then if we have those fields, we are, for example, if you think about vulnerability analysis, we are able to determine if something is, for example, compliant to CNSA 2.0, because they require the dilithium signature scheme to be used with quantum security level 5, right? So if we have that here, we can look this up and evaluate that. So next we have properties about certificates, right? So these are the properties that you have, for example, in X509 certificates, subject name, issuer name, validity periods, and so on. certificate format, the certificate extension. Then next we have the key properties.
Maybe
Yeah.
just to mention also this is something we added in the 1.5, and we gave it some sorts that we maybe can explain a little bit later. So because like when you want to describe a certificate, you normally also have a public key associated with that, but using this dependency functionality that the SBOM standard provides, it looked for us more like if you have external components that you're referencing, like you have this library and this depends on this library and this depends on this library, but for a certificate and the public key associated to it, it isn't really an external reference. It's more like it's part of it, but you still want to reference it. So we went away from 1.4, where we had it as an external reference, to internal reference to other boom reference, so another component in the SBOM or CBOM, and that is what we did here with the signature algorithm and public key, to define here a reference to another component in the SBOM. So it's a little bit different from what we saw before, but worth mentioning maybe, and also to discuss, I guess.
Yeah, very good point. And something similar we also have in protocols.
Exactly.
Yeah.
Also, I have the delta between 1.4. I sent you a message on Slack. It looks like that I pulled the latest 1.5 from CBOM. The delta does not look like it has some changes, but it doesn't have all the definition additions I see in 1.4. So maybe we can talk afterwards. But if you want to see the delta against 1.4, I have that.
Yeah. Yeah, I think maybe we can next time show the delta against the core.
Well, I mean, in summary, though, I'll just say that basically it's mainly all new definitions. Except I think that the big thing that I saw in my mind was the addition of dependency type. That was something I discussed with Basil, which would be a change to a core that I know that's come up in past discussions, but we've never done anything with dependency types. So I'll just say that.
Right. So yeah, if you scroll down here, these are key properties, right? Because I think one important crypto asset are keys, right? That are either stored in a key store on a file system and so on. And they can be like private keys, public keys, secret keys. They are in different states, right? If there is NIST SP 800-57, that defines different states where a key can be in, if it's activated or suspended, deactivated, compromised, destroyed. So this is what can be captured here.
Also, it's just to add, because from 1.4 to this 1.5, we separate from the related material to a separate key property, because we came up not only from other people that mentioned, okay, maybe key is important, so we should separate it, but also people who are doing key management software, they wanted to use this schema internally to represent their metadata about keys. So we gave it some sorts and thought it's important to add also more properties here, so they have a better way to adopt.
Yeah. And also here we have the key algorithm reference, right? Where we can reference an algorithm. You can say, okay, this is a key, this is an AES key, or this is an RSA key. And right, creation type, date, activation date, update date, expiration date. And then we have a property for, yes, we had in 1.4, we had keys actually just in this related crypto material properties, but we thought it's quite an important thing, so we have made a dedicated type for that. But here now in related crypto material properties, we have other useful crypto-related material types in there, like ciphertext, signatures, message digests, initialization vectors, nonces, right? That can be, that are related to crypto assets. Right, and then the next type here, this is protocols. Yeah, you rarely see cryptography used just, let's say, RSA by itself, right? But it's much more common to use it via protocol like TLS, IPsec, SSH, and so on. And so I think that's very important to have some ways to capture the protocols, right? So the protocol itself and also its version, right? Like TLS, there is the current version 1.1.3, right? But there are still older versions out there that could, for example, be often considered as a vulnerability itself, right? If you still use TLS 1.0. Here, like in TLS or in other protocols, we can capture cipher suites, where we have a separate definition for them that then again reference crypto algorithms via references. We have one type here for IQv2 transform type, so that's specific for the IPsec protocol. Basically about what algorithms are used there for encryption, pseudo-random functions, integrity algorithms, Diffie-Hellman groups. And with crypto ref array, we basically list all the assets or the crypto algorithms and crypto assets that are related to a protocol. Is that correct, Nicholas?
Yeah, the idea was here to, if you have a protocol where cipher suites and like key v2 vector is not applying to, you still have the possibility to list other sub-components like a key or algorithm there as part of the protocol. So, yeah.
Right. And then next we have, so the question is always, yeah, how do you identify what is a unique identifier for a cryptographic algorithm? There is one way of identifying them with OIDs or object identifiers. So there is public databases where algorithms are bound to object identifiers. So that's basically a number separated by commas. Just think there is, not all algorithms have OIDs, but still it's, I mean, if it has an OID, it's a way to capture them uniquely. Then next we have a field called confidence levels. The background for that is mainly if you think about how these C-bombs are created, right? If you have some crypto scanner that uses a probabilistic method to identify an algorithm, so we cannot be 100% sure if it's actually accurate, the results. But that's why we added this confidence levels type here, where we can say, okay, we know that it's this variant of algorithm, but we know it with confidence 1 or less than 1, right? So which can give us an insight how reliable the results are. Then the next type here is the detection context, where we can basically add some metadata about how this C-bomb was created or how this was detected. So if it's a source code scanner, for example, we can document this is the file path where this crypto asset was found, can document the line numbers, or an offset, right? If it's a binary, can document the offset, the symbol names that were associated with it, keywords, or just give some additional context about just document how this was detected. Right, so these are the main additions, and I think what follows is the definitions of some of the types.
Yep. Exactly.
Thanks for walking us through that. That was really, really useful. I have a question. I don't know. You had, let's see, trying to remember back. I think you said there was like 40 some odd entries to that NIST competition. Are all those new algorithms, can they be represented in this format today? Do we know?
Yeah, I mean, those algorithms, they fall in two categories, basically: key chems, key encapsulation mechanisms, and signature schemes. So we have those two as primitives in there, so they can be captured, right?
Right.
So they do not yet have, or not all of them have, things like OIDs to uniquely identify them, but this is, say, usually the standardization bodies like IANA or ITF or so are waiting for the standardization to be completed to assign those definite identifiers.
Yeah, so Basil and I talked about, we have lots and lots of enums here. And in most cases that they've used the existing keyword other plus unknown. And I showed, that's why I was asking for the SCVS stuff from you. So I could show them the JSON and show them like the direction we've talked about a couple of times we didn't go for in 1.5, which is probably using your URNs. So we make sure, if we know this is an evolving space, if we publish something for 1.6, we know a week later it's not going to be, the enum is going to be outdated a week later, so that we can maybe look at using URNs perhaps and describe how extend if people come with new algorithms or new whatever in the future. So,
yeah, that would be one way to do it. That was obvious to me. I mean, that list of curves was quite large, no doubt. The other possible way that we could do that is kind of similar to how we do SPDX license IDs today, where we externalize the schema from CycloneDX itself. So you actually get that strict validation if you want, but it is something else that we would have to maintain, right? So trade-offs, right? Okay. How does, question before I ask about next steps, who is using CBOM today? IBM, obviously. Are other research institutes, universities, who's using this today? Do we know?
So we are using it internally so far, right? We published it. So we have, I mean, this example of Open Quantum Safe is one adopter of it. And yeah, and we have different parties that are also interested to have this kind of interoperable format, right? I think we have like Alessandro here in the call. We also have some other participants invited in this working group, I think, that are interested in using that as an interoperable format. It was also introduced in the NCCOE project, right, which is proposed there as a format, and there are quite many vendors involved in that project as well.
Yeah,
and looking on the,
I expected more people to show up today based upon the personalized invitation that was sent out. So a little bit disappointed. Maybe we have to figure out if we can be proactive in publicizing the next meeting or something like that.
Yeah, that's fine. I think this was good for a first because it was all demos and stuff like that. So this was, I was happy with this. So thank you for presenting. But yeah, I think getting more people to the table to provide opinions and expertise, I think would be good. How does the group kind of see this going forward, right? What, in an ideal state, what would be the next steps?
Yeah, I think I mean, probably the core of it is the schema, right? Where if this should be upstreamed, I think they're work on the details there, right? On trying to have some consensus on how to upstream that, right? I think there are some details to look at there at some point. And yeah, I mean, there is also some related tooling, right, that might be interesting to look at.
Does IBM have a list of maybe it is in that PowerPoint as well, but does IBM have a list of use cases? I think the obvious one is the one for quantum safe computing, but there's obviously other use cases for this. The concept of key management was brought up, right? Using classical algorithms like triple DES to identify like existing weak ciphers. Algorithms, I think is another one. I think NIST has a list of all the different ciphers, whether they're deprecated, whether they're disallowed. So that might be another use. Is there like a document that has a bunch of these use cases kind of jotted down already?
I don't
have it as part of this deck, but I mean, I mean, basically all the like NIST has documents that there are FIPS documents that have lists of allowed and deprecated algorithms. There are other organizations like BSI in Germany that have their lists. So I think that's something that we can compile together, right, to show that there is more than NIST quantum safe, but different standards and policies
Right.
crypto use, not only.
I think currently we are just mainly driven by this crypto inventory quantum safe thing, and the other use cases just pop up, but we're not really actively searched for them. But this could definitely be a goal of the brainstorming here in this working group, to find different use cases and cover them with the same format.
Yeah, I think in general that, going back to the attendance here, just having at least differing opinions is important, even to IBM, so that we want validation for the work being done, even though it looks thorough and quite confident in what's been done. Just having other companies, other individuals from institutions, organizations that are familiar with the stuff can bless it and validate. Yeah.
Yeah, I'm going to invite some folks from our, I work for ServiceNow, so I'll invite some folks from our platform security team. They're the folks that actually write the security features, including cryptography for the ServiceNow platform. I'll invite some of those folks. If we can get some folks from, I don't know, IBM and other big organizations, that would be great as well. Is there any commercial vendors of I guess cryptographic assets that we want to invite to the party as well? The RSAs of the world, the Entrust of the world, etc.
I would say, I would invite people from CISA. And actually it might even directly invite Alan, but maybe even I think that recently Ava Black, they went to Microsoft. And so I know they're very big about protocol and ensure that they would have an opinion on this work. Yeah.
Right. Yeah, I had a briefing with CISA a few weeks ago, and the things that we're working on for 1.6, including attestations and cryptography, were both mentioned, and invitations were extended to the entire CISA staff to participate. But let me go ahead and follow up with them. I think it would be worth doing. I also have a call related. Jeff Williams and I have a call with NIST in the next week or two, I believe, regarding attestations. But I think this is also very timely as well. So we will mention this to the NIST folks as well. So I know we're at time. Thank you so much. I look forward to diving into the schema and maybe some use cases next time around, next week. And with that, have a great rest of your day. And thank you for being here. I appreciate it.
Thank you.
Thank you. It was very nice.
Thank you.